Hello students, welcome to Math with Terencia. Today we are going to see rational numbers grade 8. These concepts are based on the Tamil Nadu government Samachir book. So these rational numbers are split up into different parts that we will see later. So let's move on to today's topic. So the first chapter in term 1 is rational numbers. So we have different lessons. First will be we are going to see about definition and then on number line and standard form, comparison of rational numbers. So first three lessons, that is definition and numbers on number line and standard form, will be discussed in this part, and the remaining will be done in the next coming parts. And their next lessons are find rational numbers and the four basic operations properties of rational numbers. And also you can get all the answers of each exercise in chapter 1 in my part 6. So before going into lesson, just let's recap what we learned. We have many number systems. I'm not talking about naming number systems like natural numbers, whole numbers, integers, and this way we are going to continue with rational numbers. So what are natural numbers? I'll give you 5 seconds to get me the answer. Yes, good. Hope you get the answer. The natural numbers are starting from 1, 2, 3, 4, 5, and it never ends. So what will be the next number? Yes, you're right. It's whole numbers. Whole numbers are just bigger than the natural numbers, and all the natural numbers are inside the whole numbers. Then what will be the set of whole numbers? Yes, it just starts from 0, 1, 2, 3, 4, 5. If we include 0 with the natural number, we will get a whole number. So the next is integers that you would have learned in grade 6. Integers has all negative numbers, 0 and positive numbers. And the next bigger circle is what we are going to learn today, the rational numbers. What are rational numbers? Do you have any idea about that? Think. We come across rational numbers in each and every part of our life. Let's see some examples. There is an orange and it is peeled. We have 8 carpels and I'm going to eat one from that. So the number I got is 1 by 8. Let's see one more example. The LPG cylinder which we are using at home, you can see the net weight. The net weight is 14.2. This can also be written in the form of a different form. So these are some live examples where we can see rational numbers. I think now you can conclude how the rational number will be. Let's see the definition. So a rational number is a collection of numbers that are written in the form of A by B. In the form of A by B. And B should not be equal to 0. B should not be equal to 0. So set of whole numbers which is in the form of a fraction are called rational numbers. The number on the top is the numerator, the number down is the denominator. And we denote natural numbers as n, whole numbers as w, integers as z, and the rational numbers are represented by q, by the letter q. So here are some numerical examples. 2 by 6, 3 by 8, minus 2 by minus 6. Yes, the rational numbers will also have integers. That is what, if you recall the circle, in the rational number circle, integers will also be included. We can have negative rational numbers also. And also we can have some mixed numbers. 9, 2 by 6, 4, 3 by 8, 6 minus 5 by 12, and so on. We can see many numbers. And where we use rational numbers mostly? Most of the interest part in the bank will be in the rational form. You can say it is in decimal form. How can you say it is a rational number? A decimal form can be written in the form of a rational number. So what we can consider the decimal form as also a rational form. There is an important fact about rational number. The number are in the form of fraction, but why do we call it as a rational number? See, when we are talking about a ratio, how we will denote ratio? Most of the time we will denote ratio in the form of a fraction. For this reason, they call all the fractions as rational numbers. Rational numbers. So what we spell it as rational numbers. It's quite interesting. So now we have completed with the definition. Now we'll move on to represent the rational numbers on a number line. Let's watch a video on how to represent a rational number on a number line. So now we are going to represent rational numbers on number line. The number line is the line which represents all the numbers. So let me take this as 0, and the part which is right side of the 0 will have positive numbers and left side of the 0 will have negative numbers. This is very important as the rational numbers will have both positive and negative numbers. Let's see some examples how to represent rational numbers. So we'll see one example. Let me represent minus 3 by 4. You need to follow certain steps. First step, check whether the given number is positive or negative. For me, the number is negative. So the number will be on left of the 0 on the number line. And the second step, you need to check what type of fraction, whether it is proper or improper or mixed. Here the numerator is smaller than the denominator, so it is a proper fraction. So the number will lie between 0 and 1 usually if it is a positive number. If it is a negative number, it lies between 0 and minus 1 and 0. So now let's see, we have two methods. I'm going on to method 1. Whichever method is easy, you can follow. Here I have only negative number, so I can have only one positive numbers and then I can start as 0 because I don't want to put my number line bigger. And check the denominator. The denominator is 4. So you can write the fraction or the rational numbers as 1 by 4 2 by 4 minus. So here it should be plus 1 by 4 minus 1 by 4. Plus 2 by 4. And then coming here, minus 3 by 4 minus 4 by 4. What is minus 4 by 4? Minus 4 by 4 is nothing but minus 1. So we can stop with it. Now we can easily plot minus 3 by 4. So this is method 1. Now let's see method 2. Most of the children will use only method 1 as it is an easy. Now we'll move on to method 2. Method 2, here is we have 0. We got that the number will lie between minus 1 and 0. So here I have 1, 2, and here I have minus 1, minus 2. Now how many parts I have? 4 parts. The denominator is 4. This part is equally divided, will be equally divided. So I take this is 1, 2, 3, 4 parts. In the 4 part, I have made 4 parts. 1, 2, 3, 4. In the 4 parts, the third part is minus 3 by 4. So you count this is 1, this is 2, this is 3. So this where minus 3 by 4 lies. Next we will see another example. Example 2, 18 by 5. So as I said, you should ask some questions. First question, whether it is a positive number or negative number. I have a positive number. So my number will be on the right side of 0. And question number 2, check what type of fraction is there. Here the numerator is bigger than the denominator, so it is improper fraction. So I need to change this to mixed fraction. So how can I change? 5 times 3, 15. So whole part, 3 parts I have. 18 minus 15 is 3. So 3 by 5. So now we can easily understand the whole part is 3. So the number lies between 3 and 4. The number lies between 3 and 4. So if I go with method 1, these steps are not necessary. Now I'm going to solve this in method 2. So I know here is 0. And I know the number lies between 3 and 4. So 1, 2, 3 and 4. And here I have minus 1, minus 2. So I have 5 parts. So you need to make 1, 2, 3, 4, 5 parts. And then this is the third one because the numerator value is 3. So 1, 2, 3. This part will be 3 by 5. So the same question I can solve using method 1. Method 1, you don't want to convert anything directly, you can pull out, but you need to write lot of numbers. So I know the number is in right side of the 0, so I have my negative numbers less. So here the numerator is 5, so I write minus 1 by 5. And then I start. I write 1 by 5, 2 by 5, 3 by 5, 4 by 5. The method 2 is easy to work. You don't want to write more, just you need to think. But method 1, you need to write many numbers. 5 by 5 is equal to 1. Same way you need to go 6 by 5, 7 by 5, 16 by 5, 17 by 5, 18 by 5, 19 by 5, 20 by 5. 20 by 5 is nothing but the 4. And if you see 15 by 5, 15 by 5 is equal to 3. So the number lies between 3 and 4. So 18 by 5 is here. So this is how we will plot rational numbers on the number line. So hope you are very good how to represent the numbers on the number line. As I said, decimals or the different form of rational numbers. Now let's see how we can change a decimal into a rational number. Let's watch a video for this. Okay. So in this video we are going to see how to write decimals as a rational number. Before that we should know something about decimals. In decimals we have terminating decimals. What do you mean by terminating? Terminate means stop. The decimal value will stop 3.6. It won't go beyond this, or 3.63. That's it. It won't be continuing. So that is terminating decimals. Non-terminating and repeating. When you divide certain numbers, the number will not stop, but the value will go on 666. The 6 will be repeating. So this type of decimals are known as non-terminating and repeating. And also we have certain decimals which does not terminate and does not repeat. We can't predict the numbers which will come. So those type of numbers will be 1, 0.1, 2, 3 and so on. We don't know. We can't expect what number will come before, after. So these type of numbers are known as non-terminating and non-repeating. Though we can write all the fractions, all the decimal numbers as a rational number, we cannot write non-terminating and non-repeating decimal as a fraction form. So this type of decimals will not come under rational numbers. For example, the value of pi. We know the approximate value is 22 by 7. But when you divide, it will be as a non-terminating and non-repeating decimal. So the values like as pi, if you go in future in grade 11 and 12, you will come to know different non-terminating and non-repeating numbers. As of now, you know pi, so I am mentioning as this. So these fractions will not be considered as a rational number. So this is an important fact about rational numbers. We can't take all the decimals as a rational numbers. So now let's move on to our own topic. How to represent decimals as a rational number. Example 1, we will write 0.6. 0.6 is a decimal number. So first step, go with 0.6 by 1, because all the whole numbers or all the rational numbers will have the new denominator as 1. Now count how many decimal numbers are there after the decimal point. So I have 1. I have one digit, only one digit 6. I have 1. So multiply by 10. If you have 2 digits, you need to multiply by 100. One decimal number, 1 0. So now you will get 0.6 times 6 is 6. The decimal point will move towards right one digit. So 10 multiplied by 10, 1 multiplied by 10 is 10. So the value is 6 by 10. So this is the fraction form, but it is not in the standard form. Okay, we need to write all the rational numbers in the standard form that we can see in the next part. So this is how we will represent the decimal number as a rational number. Let us see one more example. Example 2. We can even take negative fractions also. So let me take minus 2.35. Don't bother about minus sign. All the processes are the same. So have it as 1, the denominator. Now you count after decimal point. I have how many digits? 1, 2. So I need to multiply by 100. So minus 2.35 multiply by 100 by 1 times 100. So when I multiply by 100, the decimal point will move 2 digits towards the right. So the answer will be 235 by 100. So you know this is an improper fraction. We can try to have it as a mixed number. So how many hundreds are there? I will have 2 hundreds. So 2 will be the whole number. So 235 by 100, and this part we need to try to write in the standard form. So next video we will see how to represent the rational number in the standard form. So now let's see the standard form, how to represent rational numbers in the standard form. If in a rational number, the only common factor of the numerator and the denominator is 1, then the number is said to be in the standard form. Here are some examples of numbers which are in standard form. If a rational number is not in the standard form, then what can we do? We can simplify it to get the standard form. So now let's watch a video on how to represent numbers in the standard form. Okay. What is standard form? We saw before what is a standard form. The number cannot be reduced further. That is the common factor for both the numerator and the denominator of a rational number will be 1. We cannot divide it further, both the numerator and the denominator. So now we have here also we have two different methods. So let me consider one number 48 by minus 84. So the first standard step should be the negative sign should not be in the numerator. The negative sign should not be in the numerator. So the first thing we want to notice in the standard form, the negative sign should not be in the numerator. It should be either in the middle or near the numerator. Okay, so that is up to you. So now I am going with minus 48 by 84. In method 1, you need to think in which table we will get 48 and 84. That is, which number can divide both 48 and 84. So I can say I can divide by 2. Both the numbers will be divisible by 2. So when I divide by 2, what will I get? I get minus 24 by, when I divide 2, 4 2s are 8. Now again, which number can divide both 24 and 42? Yes, it's 2. So I have found the common factor as 2. So I need to divide by 2. 24 divided by 2. I have a minus sign, so minus 12. And 42 divided by 2 is 21. And now, I can't divide by 2. Then which number can divide both 12 and 21? Is 3. So when I divide, what will I get? I get minus 4 by 7. Now you need to think whether I will get a common factor for 4 and 7. No, I will get only 1. So I cannot reduce it further. So this is the standard form of minus 48 by 84. This is method 1. Now we'll move on to method 2. I always use the word common factor, common factor. Only that is the key word for method 2. So I'm going to find the highest common factor, HCF or GCF. So let us work for the same number. 48 by minus 84, which is equal to minus 48 by 84. Now we are going to find the HCF of 48 and 84. Always have the numerator as the first number and the denominator as the second number. So when I go with HCF, it's 2. 2, 24, 42. Again, it's 2, 12, 21. Again, it's 3, it's 4, 7. So the HCF is this, is 12. 2 times 2, 4, 4 times 3 is 12. So I need to divide this fraction by 12. When I divide by 12, I will get minus 4 by 7, which is nothing but this one. So this will be the numerator and this will be the denominator. So you can directly write as minus 4 by 7. So this is the method 2. If you are good in HCF, finding the greatest common factor, this is the easiest way you can follow. Hope you all enjoyed my video in the part 1 of rational numbers, and keep calm for some time, and we'll see you soon in the part 2 of rational numbers. Thank you.